Hey everyone, a quick addendum to the converting polar integrals video. I think that's video number 41. Let me double check. Converting polar integrals number 40. All right, so yeah, converting Cartesian to polar is video 40. This will be the addendum to that video. Apologize for the AC running in the background for right now, but I figured it's just going to be a quick addendum video, so there's no reason for me to go turn off and turn it back on. So what do I want to talk about? I want to talk about when do you know to convert Cartesian integrals into polar integrals, okay? And there are two big giveaways. The first one is, looks like a glitch there, but I think we're good. The first one is if you have some double integral and you have like x squared plus y squared in the interior, right? And let's say that's dA. If you have any kind of x squared plus y squared, it could be even like 1 divided by 1 plus x squared plus y squared, right? As long as you see an x squared and you see an y squared and they're added together, you should convert it to polar integrals then. Another thing that I didn't really talk about then is when you have like the following scenario. If you have some double integral, all right, and let's say your bounds are -1 to 1, and the square root of 1 minus x squared, square root of 1 minus -1 minus x squared, right? And then you have, then this would have to be dy dx, okay? And so why is this a sign to tell you to convert into polar integrals? Well, these two guys, when you have a square root of like something minus y squared or x squared, it doesn't matter, as long as it's something minus x squared or y squared, and it's under a square root. You look, okay, so here's y, so that tells me that's y equals, and this is y equals this guy. All right, so now let's take the bottom one. Why not? So I have y is equal to negative square root of 1 minus x squared, right? What happens if I square both sides? I get y squared is equal to 1 minus x squared, and look, x squared plus y squared is equal to 1 after adding x squared to both sides. So yeah, I mean, we know what this looks like, right? That looks like a circle with radius 1. Oh boy, that was bad. That's a circle with radius 1, right? And then, okay, so y then goes from negative this guy. So the negative part, so dy, right? Here's an arrow in the direction of y. I guess I'll make it blue because y is the inside integral, right? So y would hit the circle on the bottom and then it hits the circle on the top, right? So this is essentially the bottom half of the circle, and this is the top half of the circle, right? And so that's what's happening over here. So this is also why you know to convert into polar integrals, because this then you get a circle x squared plus y squared equal to 1. Well, now you have your, when you draw that out, right, you're going from the bottom and you're hitting the top of the circle, and then for x you're going from -1 to 1, so your region is just the entire thing. Well, now if you convert this to polar, right, it's just some double integral r dr d theta. Remember the r when you're converting, and now what is it? Well, r just goes from 0 to 1, right, because it's a unit circle, and then d theta looks like it goes from 0 to 2 pi. So again, it converts this really tedious integral with square root signs into a polar integral that looks very nice. And I mean, it doesn't. Only one of these guys has to have square root, right? Not both of them, because you look. I took the bottom equation. I took this one and I squared both sides. If you take the top equation and you square both sides, you'll get the same result, right? And so these guys more or less just tell you to look for what your region is going to be. So again, let's say I had some double integral, and let's say this was what is it? Let's say it was like -1, or let's say -4, 0, or let's not do that. Let's do 0. Let's do 0 to 4, and then let's do 0 to or negative root 4 minus what do we want to do? Y squared? Yeah, let's do that. 0. Okay, and now I have dx dy. So what does this region look like now? Well, this guy, right, x is on the inside, so that's x equals, and this is x equals. And so if I square it, I got x squared is equal to 4 minus y squared. So I got x squared plus y squared is equal to 4, right? So drawing this out, so I have a circle of radius 2, right? So that would be 2 right there. And then, okay, cool, x, right, dx is going to be this guy, right? That's dx through my region. And look, it hits the negative side, right? So it hits the negative side of my circle first, right? That's the negative side. And then it hits 0. So that means I get stopped at 0. All right? So right now I'm only on this highlighted half, right, essentially of the circle because of drawing the dx guy, right? I hit the negative side of the circle, that's this bottom guy, and then it hit 0, which is the y-axis right here, right? And then what? And then I look at y, and this really should be from 0 to 2, because otherwise it wouldn't make sense, And so y would go from 0, which is here, right, to 2, which is up here. And so that means if I go through this highlighted stuff, you'll realize, oh, my region is only this top left quarter, right? And so when I do the conversion into polar, I get, right, dx dy becomes r dr d theta. What is r? Well, r is still, I'm still always going to be from the origin going to a point on the circle, right? So the origin is always 0, and then everywhere on the circle is equidistant from the origin, which in our case, this circle is radius 2, right? Since here that's 2, and this equation tells us it's a circle radius 2. And now for theta, what is theta? Well, my region is only this top left region, so I go from here to here, right, where the orange lines are. And so that's going to be theta from pi over 2 going to pi. And so we see we got pi over 2, and we're going to pi. And so this is going to be the conversion from dx dy into this guy with my polar integral. And of course, if you had some function in here that had x and y's in it, you have to make your substitution. X equals r cosine theta and y equals r sine theta. But I mean, the bounds are going to be more important. The bounds are going to be what you're going to need to be used to finding in these problems. So, all right, that actually went a little longer than I thought it would, but I feel like it's a good addendum video to have, and hopefully this will make converting from Cartesian to polar, first of all, you know when to do it, right? The bounds or the function gives you a hint. And then the second thing I wanted this video to show was then just more examples of actually doing that conversion from the bounds to from Cartesian to polar, and I think I did that. So I'll see you guys in the next video, and yeah, that's it.